Hello everyone, and a very warm welcome to today's webinar, Making Math Accessible One Step at a Time. My name is Richard Orme from the DAISY Consortium, and I'm your host today. Let's get this webinar started. I'm delighted to hand over to our panelists who will introduce themselves and share with us how to make math accessible one step at a time.
Hello, nice to meet everyone. My name is Alex Cabral, and I'm a user researcher with Benetech on the Diagram Center.
Hi, I'm Matt Nupin. I'm the project manager for Mathshare. I'm a former high school science teacher as well, and also have a child with special needs, which gives me a special connection with Mathshare and our projects at Benetech.
I'm Abby James. I'm an accessibility consultant and researcher based in the UK. I work closely with the British Dyslexia Association, and I've worked on a number of projects over the years to look at how assistive technology can help students with learning difficulties in maths and science fields.
Yeah, just for a quick overview of what we're going to cover, we're going to set the scene and learn how to support students with learning disabilities through showing work, as well as developing number sense and teaching concepts in a multimodal format. This is primarily directed toward teachers and AT specialists and other professionals who are working to support students with these learning needs. And at the end, we'll have time for a Q&A.
Great, thank you. So just to set the scene a bit, as somebody who has worked within the assistive technology field for nearly 20 years, math is often an overlooked area, but actually about 1 in 5 children have specific disabilities around learning and processing and attention. That's the same in the US, the UK, and many European countries where we have data. And these students are significantly more likely than their peers to repeat a grade or drop out of school or not achieve school leaving qualifications in mathematics. And the impact of learning disabilities can continue into college with lower number of disabled students studying science, technology, engineering and math subjects. And for example, I've been involved with projects with undergraduate engineering students with dyslexia who continue to have problems with accuracy of mathematics and reading content as well. And the reason why these students struggle with learning maths is that maths requires lots of executive functioning skills. In particular, it relies heavily on working memory. It relies heavily on organizational skills, reading skills. There is a lot of reading in maths. It requires a lot of attention and focus, and also particularly reliant on spatial and sequential processing skills. And one of the things that's also been picked up in the research is often if people are anxious, then that really affects their executive functioning and their working memory and all these skills. And there is a sort of a cycle with mathematics that people get into anxious about doing maths, and that can lead then to actually more problems as well. And one of the difficulties with developing maths concepts is it relies on solid number sense, such as coexistence between parts of a number and its whole, and understanding lots of abstract parts. So you have to have a good foundation of all this knowledge and be able to access this knowledge quickly in order to apply mathematical problems. And finally, just to set the scene from the point of view of some of the research that I've done in the UK, when we've been looking at assistive technology and how it can help our learners through schools and colleges, is that accessible maths, if we can provide it in an accessible format, it could support with decoding that can help with problem solving and accuracy. But one of the things we've been really limited is access to assistive technology and also to accessible formats as well. So there's a little cartoon on the screen which have got somebody scratching their head looking at an equation on the board, and if I was to have an inaccessible document, one that hadn't been formatted correctly with maths, and I put that through assistive technology, likelihood is it would be read out as something like hx equals x2 plus 5 slash x dash 1, that first sentence at the top, which really doesn't make sense. There's no mathematical sense within that. As soon as we start to get good assistive technology and accessible content, we can then offer support such as the second row, where it can read aloud as h of x equals x squared plus 5 over x minus 1. Immediately, we are converting that visual representation of maths into something that makes sense. Or we can go further and have a full description for somebody who is sight impaired, where it's h of x equals start fraction x power of 2 plus 5 all over x minus 1 end fraction. So if we have good assistive technology and accessible content, we can really provide a lot of support. Now, I've been working in the assistive technology field for 20 years. I am dyslexic, and I actually started in a completely different science field, initially as a meteorologist, and I was so shocked when I moved into assistive technology about how little support there was for helping maths. That has improved over the last 10 years, but I'm really excited today to be talking with Matt and Alex from Bookshare to hear about some really exciting innovations within this field, because it really feels like we're turning the corner and starting to get the technology we need to help learners. So I'm now going to pass over to Matt, who's going to talk about some of the work that Mathshare has been doing.
So I worked as a science teacher for 12 years, and I did a lot of math, and I was always kind of working with at-risk teens who often had unrecognized disabilities and were seen as kind of being lazy or uninterested. And because one of the big issues is that educators are often unprepared to help students with learning disabilities succeed. And so, you know, we're grouping into that of like parents and teachers and tutors who may not be aware of the different tools and strategies that are necessary to facilitate math learning. And this is compounded by the fact that these disabilities are often hard to diagnose early on. And this will lead parents and teachers to view these symptoms as just simply laziness or misbehavior. And so, because again, going back to my experience as an educator, my room was filled with those students that were seen as, that were kicked out of school for misbehaving or just simply were uninterested in education. But by working closely with them and utilizing different tools, then we're able to really address what were the reasons why students were falling behind and what were those behaviors. And so being able to really target those needs that the students had. Showing your work is an incredibly important learning skill. It's not just simply just about assessment, it's about the learning process. And so the National Council of Teachers of Mathematics advocates the promotion of thinking and reasoning as a basis for conceptual understanding of math. One of the most meaningful ways to improve student learning is through day-to-day formative assessment. So, however, you know, the issue is that most online math editors and math tools that are out there only allow students to submit the answers. Either it is just simply a very simple fill in the blank, or it's a multiple choice, and there's no opportunities for students to actually work through the problem or show their process. And so this makes it extremely difficult for students to track actual understanding of the problems and concepts that can lead to the frustration and decreased confidence over time, which again goes back to a lot of these issues of where then it seems that students simply are uninterested or unengaged or kind of misbehaving. So I would now like to share, Mathshare is one of the tools that we've been working on. So it's available at mathshare.benetech.org. Mathshare is freely available to all teachers and parents and students. And our big focus is about that step-by-step process of working through the problems. Mathshare isn't designed or meant to be a tool that is going to teach you math. There is a wealth of amazing tools like that, but they're all missing this critical piece of allowing students to work step by step through it. It is completely free. It is an open source program. And so I'm gonna go ahead and just simply show you how students can work through this. So this is the Mathshare editor right here. And I've already begun the problem right here. We have it set up so that the prompt up here at the beginning is very clear. Students, for this one, students have the instructions of solve for x and our problem of 2x plus 4 is equals to 10. That's automatically played as step number 1. Now, step number 2, this one I've already worked through as the student. And this is one of my favorite things as a science teacher of that it's been crossed out and the explanation here. And this is really kind of what sets Mathshare apart from all of those other kind of learning tools is that students have this dedicated step-by-step process and a place to actually explain their work. So I'm going to just simply finish up this math problem here by solving for x. So I've got here, I need to divide by 2. So I'm going to subtract 2 from both sides. And over here, I'm going to explain what I'm going to do.
By way of audio description, at this point, Matt clicks on a button marked Dictate, and it transcribes his speech for explaining his reasoning.
The last part I need to do is to get x by itself. And so to do that, I'm going to divide both sides by 2. And I'll stop the dictation. So it's automatically put in the speech text there. And some of the things that's really neat that we have that are built in here. So you can see all of our math tool palette down here. We have keyboard combinations for each of these. If this, what I can do is I can use this calculate tool, which will then automatically cross that out and do the math for us. And for right here, I know that this is going to simply end up being x. And I'll add my step. And now it's cleaned it up. So Mathshare automatically looks at what you've crossed out and then gives you that nice cleaned up step of then x is equal to 3. And when students are done, they can just simply select finish. They'll be done with it. They can go back and they can edit through it. And so again, just to show you again, this step-by-step process of 1, 2, 3, having these cleanup steps, having a place to be able to explain your work as you're going through is something that is a necessary part for students to develop their own mathematical thinking and problem-solving skills. All right, so I'm going to now hand it off to Alex.
All right, thanks, Matt. Share my screen really quick. All right, so the second point of what can really help a lot of these students is helping to develop number sense. This can be bolstered by working with students interactively on concepts. It can be done as particularly using real-world examples, such as comparing lengths of familiar objects. So like to the right here, I have a ruler, but one of the first things that a lot of teachers use is comparing things that students can either see or feel or touch that they're familiar with, of seeing like, this is about half the size of this object. And it can also be aided by focusing on the process rather than the solution. So one of the tools that I wanted to share with you is these PhET simulations, which are done by the University of Colorado Boulder. They have a number of accessible simulations, which are also accessible through screen readers. So this one is on Ohm's law, and under here I have V equals IR, which is Ohm's law with the V is larger than the I and the R smallest.
Pausing here for some audio description of the PhET demo, that's PhET. What's shown on the screen is V equals IR. And 2 sliders on the right allow you to raise the voltage V or resistance R. As you raise the slider for voltage, the V and I in the equation become larger. It also shares a sound, rising in pitch as the voltage increases. As it is decreased, the V and the I become smaller, along with a decreasing pitch.
So in this demo, what this is showing on the screen is V equals IR. As you it shares it also shares a sound on the as the voltage increases. You can also, either by exploring with a screen reader or just viewing visually, you can also see the I decreasing as well. So this would be particularly helpful for older students who are still trying to grasp how algebraic equations affect each other. So how numbers actually interact to create what actually is. So for the third point, multimodal learning. This can also help students consolidate what they've learned. A lot of research has shown that not only adapting to students' learning styles, but actually showing concepts in multiple formats can really help students understand and consolidate that information more effectively. And this is also very necessary for many students with learning disabilities. It helps them to understand the concepts in a way that really works for them. So this can help to support visual, auditory, and tactile kinesthetic learning. This one, I actually have a story from one of the students that I've been working with. So she has she has severe math anxiety, as well as an undiagnosed learning disability. Math was incredibly difficult for her, and when faced with a complex problem, she didn't really know where to start. However, we were actually able to present her with a sketchpad so she could draw out the problems, and she actually ended up turning the math problem into an art problem and understood a lot of these concepts that would have been lost to her otherwise. And this is really just to illustrate that students with these learning needs, they can really freeze when they're faced with a lot of these numbers and complex math problems. And by supporting other skills like drawing and art, you can help them find patterns that they wouldn't find otherwise. Some of the tools that can be really helpful in the classroom. For the tool that we used, that was with Mathshare. This one, so this should look familiar, or if you get a chance to try it on your own. There's actually this is the problem view within Mathshare. It has step 1, solve for X. A car moves at a constant speed of 50 miles per hour. How long does it take the car to go 200 miles? And there's a sketchpad beneath. This is particularly helpful for a lot of the students we've worked with learning disabilities, particularly dyslexia and dyscalculia. Working through it visually can be very helpful. For in this case, there are a number of different shapes you can use, changing the line color, so changing to red, and actually being able to draw the problem of a car going down the road. So I'm drawing a gray line here going out from a red box that is my car. Then I can divide this line in half. So I know, okay, this is 2 pieces. And if I divide it in half again and again, then that's 4. And as a student using these pictures and drawing and other skills to actually think through the problem, it can really help understand in a different way. So in this case, it would be 4 hours, because if they're going 50 miles an hour, 200 miles, that's just a simple example. Another option is Desmos. I really support as an accessible learning tool. They have interactive graphs, which can be used for both sighted students and students who are blind or visually impaired. So this is an example of one of the tools that you can show with Desmos. So in this case, I have on the screen x squared plus bx plus c, which is a standard parabola. And there are these sliders that you can control of b equals 0, c equals 0. As you increase b, the graph reacts accordingly. So rather than students having to graph these out every time or not understanding how these numbers are interacting, they can actually play with it and see, oh, this actually, as I'm going down, it's going in this weird pattern that looks almost like a reverse parabola. Or as I increase c in x squared plus bx plus c, the parabola translates up and down the graph, up for positive and down for negative. And this can help them understand the patterns, which are really central to understanding math and STEM concepts. So in conclusion, it's really important to support these students by using accessible math tools to help them show work, to help develop this number sense, and to use different modalities to help solve and think through problems. I've also included, for when the slides are shared, a list of the resources, the tools, and links to them, Mathshare, PhET, and Desmos, as well as contact information for Abby, me, and Matt.
Abby James can be reached at Abby, A-B-I, at assistivelearning.co.uk. Alex Cabral can be reached at Alex C, A-L-E-X-C, at benetech.org, benetech.org. And Matt can be reached at Matt N, M-A-T-T-N, at benetech.org.
And now we lead into the Q&A.
Thank you so much to our presenters for leading us through that and for dealing with the time so well. It's always hard to keep these demos to time. So we get to questions now. We've got some queued up, but if you have questions that you'd like to ask, now's a good time to add them into the Q&A. Let's start with a question from Sarah. And Sarah is asking, do any of the tools that we've been looking at today allow for students to complete their math work vertically versus horizontally?
Yes, and here I'm going to share my screen real quick. I saw that question, so I queued up a part. So in Mathshare right now, the being able to work vertically is something that we are going to be building upon, that ability, but I wanted to show you how it currently works within Mathshare. So here I did the same thing, but instead of then working horizontally, then we did vertically, so -4. So if I select that 10, it's what we call our stack below tool. And so if I do that, and then I can say -4, and the calculate tool will also work. So you could then use the calculate tool, and it'll automatically then do that. We are kind of working on, but it'll be later on, of being able to kind of like expand out that being able to work vertically. But for right now, this is how you can work vertically within Mathshare.
That's wonderful. We have a question from Varun, from Jeff, and from Blind Educator. They'd like some clarification, please, on the accessibility of Mathshare and maybe some of the other things you showed for screen reader users. Who'd like to take that?
So I can take that. So for Mathshare, it's currently we're working with Sina Baram and his group to make it accessible for screen reader users. It's currently in process. The other two that I showed, Desmos and PhET, are both accessible via screen reader users. And the link that I shared was specifically to PhET's accessible simulations. So those are accessible for both NVDA and JAWS, as well as VoiceOver on Safari. And then Desmos not only has the sonified graphs, which are accessible via keyboard for different screen reader users and combinations, as well as they have support for Nemeth Braille as well.
And another screen, sorry, was that maybe Matt coming in? No, okay. So still sticking with screen readers for a moment, thinking about the use of charts that might be in a question. I don't think we saw this in the demos, so what kind of possibilities might there be for a screen reader picking up charts in a question, and maybe some related to that? I didn't quite get the question, but identifying the use of color within a question. So what's the situation with access to charts? Is that something that was within scope for Mathshare or any of the tools that you've shown, please?
So currently Mathshare does not use charts. So I'm not sure I can speak to screen reader usage for charts in Mathshare. Desmos does use charts, and they do allow going into the charts to explore through them, similar to how they allow for the exploration of the graphs themselves. And then PhET, I also believe, does not use charts.
Thank you.
Mm-hmm.
So a question from a couple of folk around the costs for using the different things you've shown today. Maybe Matt and Alex will speak to those.
Yes, that was, I should have led with that. That was part of my intent with sharing these programs, is these are all free for teachers to use in classrooms. They are varying levels of open source. I believe Desmos is proprietary, but still free.
Thank you. Lots of questions specifically on Mathshare. You showed a demo using voice input there, Matt. I think you were showing us that. Is there any support for handwritten math? So maybe entered from an iPad or a drawing tablet? Is that an input method that could be is supported now or could be in the future? This is a question from Steve.
No, so handwriting input is not supported right now for Mathshare. We've been trying to focus very much on kind of like some of the input tools that we have here. It's something that we've received requests for, so definitely the more messages that we receive from people, the better. But we don't have like handwriting recognition input as something that's available right now or in the immediate future.
Question to Abby. Do you know from your extensive knowledge of assistive technology, are there ways maybe of using a third-party tool to handwrite, which then might then enter into an area where you would normally be typing with a keyboard? Is that a thing?
Yeah, so there are some tools with handwriting built into them. There are some specific apps that have handwriting, and I'll try and dig out the links for them so we can share them afterwards. It's built into the Text Help Equatio tool as well. I always have a bit of a caveat with maths recognition, because when we tried it out, it's about 50-50. You have to be quite accurate with making sure all the symbols are drawn accurately. When you're doing handwritten recognition of a word, we have lots of technology now that can recognize that and spell correct it, but with equations it's still on a single symbol basis, so it's not ideal for everybody, but the technology is around.
So two related questions, one from Kathy and one from Caitlin. So Kathy's question is, in Mathshare, can you save your work or print it out after you've worked through a problem? And Caitlin asked, what do the saved answers look like on Mathshare when you're done with your work?
I guess I can take that one. So for the saved answers, you can either save a link if you don't want to sign in, or you also have the option to sign in to, it'll save any of the problems that you've worked on a dashboard so that you can access them later.
Thank you. And another question, I guess, related to the whole, once you've used Mathshare, what can you do with it? We've got a question here from Shannon, which is, how do you input this work into maybe a Google Docs to share online with teachers? How does that bit work?
Oh, so this can actually be shared through LMSs fairly easily. That's part of why we went with links for sharing the answers. So you can either share it as Matt is demonstrating on the screen, clicking through share permalink, copying the link and closing. There are also options to share to Google Classroom as well as Microsoft Teams, and building out more options as well, but it could be shared directly to Google Classroom.
And does that, forgive me, I don't know that well, so would that then allow someone to put it into a Google Doc, or is that is it a specific LMS, Google Classroom?
This is responding to the need to share with teachers. So if they needed to put it into a Google Doc, they could include the link. Or if they needed to share with their teachers in another way, either a different LMS or through an email, they can also include the same link.
I want to add in real quick of one of the big things is just that, the information could be copied and pasted into a Google Doc, but that structure and ability to navigate through in an accessible way is lost once it would be transferred to a Google Doc. So that's kind of why we focused on specifically users would have to come to Mathshare, but we've tried to make that linking as easy as possible, like Alex was saying.
We have a couple of related questions, one from Stephen here, which is Mathshare able to take MathML or LaTeX as an input format? And then we have from John, can this be exported to MathML, and can we import MathML into this tool? So again, lots of interest about kind of importing and exporting from Mathshare.
Absolutely. So Mathshare is actually built on MathML. So you can use MathML or LaTeX as an input format.
And for outputting?
That is a good question, and I could probably get back on that, but there should be a way to fairly easily export it out to an MathML or LaTeX format, or if not, we can build it out as well.
We have a clarification question in here, which is that Mathshare, it's up there on the banner there as beta. Could you just tell us a little bit about the kind of status of Mathshare and whether it will move to kind of production mode? How's that going as a development?
Yeah, so
go ahead, Matt.
Okay, it's ready to be used by teachers and students right now. We have a number of educators that have been using Mathshare during this school year. Right now, our focus is on rolling out some features that are focused on students with learning disabilities, and then we're going to be focusing more on rounding out the screen reader accessibility and then Braille and switch access. And so when we say beta, our focus is, I guess, it's really because there's a number of features and functionality that we're actively adding in, and we're focusing very heavily on the accessibility piece. So we do kind of plan on being in beta for at least like the next year. But with that said, it is something that is ready to be used within the school settings right now. It has been.
And you've talked a lot about students with specific learning disabilities. You see, we've had quite a few questions about screen reader access. You talked there about working in the coming period on screen reader experience and maybe polishing that. We have a question in here about what's your kind of timeline for full screen reader accessibility?
Our focus for that is going to be on this summer. So we're looking at early next school year when that kind of fully reviewed, rounded out screen reader accessibility will be launched is going to be early next school year.
Thank you for that. So sticking with accessibility before we switch tack a little bit, we've talked about screen reader technology, maybe JAWS, NVDA, that kind of thing. But would Mathshare or Desmos be compatible with read aloud options? And we're thinking here of read and write for Chrome or speak in Mac.
Yeah, so we're aware of the different browser extensions for the text-to-speech read aloud. Because they kind of work in different ways and not all students have them, we're actually going to be adding in text-to-speech within Mathshare. That's going to be launching this spring, early summer, where we'll actually have then text-to-speech buttons with individual steps as they're going along. So a student could then simply select a button that's in the My Work section, and then it will read out the equation and then the explanation as they're kind of going along. So we are going to be building that out so that it's just simply integrated within Mathshare. Some of the read aloud browser extensions could be compatible with Mathshare. Not all of them are, because again, the way that they interact with the page is kind of different. Mathshare is very different than your traditional, basic text on a page. So I can't really give any promises on which ones Mathshare will work with, but we are going to be releasing built-in text-to-speech.
Abby, in your opening remarks, you talked about the frustration with a lack of assistive technology that works well in math. I wondered what your kind of thoughts are of having seen some of the things that our colleagues have shown us here and hearing that Read Aloud is coming to Mathshare, and what you think still needs to be done.
I think it's some really great innovations, and I've seen early versions, so it's really good to see how far it has come along. I think it's interesting also looking at the questions. This is another piece in the jigsaw. One of the reasons why browser extensions like Read Aloud and things like that within Chrome have limited impacts on maths is because of the lack of support for MathML. And that whole sort of workflow through from creating maths in a nice format that can be read aloud and coming out then in an accessible format as well. And I really liked the graphing tool as well, to see that type of a conceptual tool as well. But it would also, we've got to link that up into things like Google Classroom and Microsoft Teams and OneNote that are being used within the classroom to actually then share that with teachers. In the UK particularly, we find it's the children with special needs might have a laptop, but they then still have to go back to a non-tech solution to supply it to a teacher. And I'm sure that's the case in many other countries as well, where we don't have classrooms full of laptops. So we need to get this AT integrated into the teacher's workflow as well.
And you talked about different countries there. We have a question from Jan, which is, are any of the resources that we've been showing today available in languages other than English? What do we know about that?
So currently Desmos is available in a number of different languages, I think at least 10. Mathshare is built so that we can expand to other languages, and I believe we're looking at that within the next year. But currently it's primarily in English.
Can I ask a follow-up question of Alex? Will your text-to-speech just be in English, or will that have language options on it as well?
Currently just in English, but the way that it's being built out is so that it can be scaled to other languages later. So it's not being precluded.
We have a bunch of questions here around what kind of levels of math education these tools relate to. We have questions around can it be used for college level physics or other college maths? We've got, would this resource be useful, say, for a math major who's using higher level maths? And other questions around the complexity. So maybe if we have a complex nested equation with nested parentheses and division lines, and the ideas around how kind of tagging that and making that accessible. The question is around kind of screen readers, but it talks to the kind of the level of math problems that these tools relate to and the level of education where you feel they're most applicable. Could you speak to that, please?
I can start with that one. Yeah, so right now our focus is on the middle school, like upper elementary to high school, focusing on algebra. The tools that we've built Mathshare off of have a lot more mathematical functions and abilities built into it for calculus and statistics. And that's something that we're working on. We're working on a new kind of like tabbed interface for the math tools that will allow us then to be able to add in more math functions without increasing the cognitive load for users. So for right now, our focus is very much on basically like middle school algebra, but that is in our roadmap of launching out math functions that is needed in higher grade levels. Some of them, like matrices, we've had a lot of requests for long division, which is more elementary. But yes, we do have that as something that we're going to be releasing, is the functions for within calculus and statistics and Greek alphabet. If there's like functions that are more specific that people kind of need, please let us know. That is something that we are going to be expanding out this spring and into next school year. So the more feedback and kind of input that we get and how people will be using it, that'd be fantastic. But that is our plan, is to build that out so that it can be used beyond just simply high school. Because certainly the students that we want using Mathshare now, when they get to college, we want them to be able to use Mathshare, be able to continue using that platform.
Wonderful. So one question starts with, sorry to be a dummy. Nobody's a dummy here. If you have a question, then probably other people have that question too. Asking about how the educator actually enters the problem into Mathshare, and a related question from Alice, which is, how would a student in a college course be able to use Mathshare to solve problems or to demonstrate how they solve problems from a published textbook?
Okay, these are both excellent questions, and I agree with Richard. That is not a dumb question at all. So how a teacher enters these problems is through, Matt is actually demonstrating on his screen right now, hovering over create a problem set, which is located at the top of the page in the dashboard. It allows you to select the button palettes available for the problem set, which actually relates to which grade levels this is applicable for. So if you want students to be able to access different geometry tools, they can. But if you don't want them to get distracted, you can also leave those off. Then if you go to next, then it creates a problem set where you can add new problems. So you add both the problem itself as well as the prompt. So in this case, solve for x for 3x plus 2 equals 10. And if you press done, it shows up in this problem set that you can share with your students.
And what about that question about a student themselves using this to demonstrate they're working for something they're doing perhaps from a published textbook or an assignment that's been sent to them in a different way?
Yes,
Would a student, yeah.
So that's, there's actually another program going on at Benetech around accessible math called Math Detective. That's around OCRing math effectively from textbooks. That's something that hopefully we could link up to in the very near future. So having, if there is, particularly on Bookshare, just because we are very close with Bookshare, having links within the actual textbooks themselves so that if there's, say, math in the textbook, you can actually click that link to bring it to Mathshare so that you can solve through those problems. Barring that, also it's possible to create extensions to actually put in the math equations directly into Mathshare so you don't have to rewrite them. But if you have, say, a paper textbook that you want to work through, a student can actually create their own problem sets and then also work through them on their own and either choose to share their answers or not.
Thank you. And I love the way we're doing live demos in response to the questions that are coming in. That's super. So you've showed us how a problem set can be created, and we just saw that happen live. A question here from Kelly, which is, are students able to input problems and show their work of solving the problem using verbal means, i.e. Voice input or voice control, or is motor function required? So have you looked at this with voice input technologies?
So we've done some work with voice input technologies. So for the prompts and the working through the steps and the explanations for the steps, those can be given verbally. However, giving the math itself, that's something that's much more of a significant problem. And actually, Abby, I wonder if you know of math dictation tools that are particularly well-crafted that can interpret spoken maths effectively.
So it's a really complex problem because we don't consistently speak maths in the same way.
Or even the word.
Yes, even the word. Sorry, I keep saying maths, not math. And even between British and American, what we found in the UK is a lot of how we pronounce and say even symbols on screen is differently, and I'm sure in other English-speaking countries, before we get into other languages, also speak differently. So while there are some technology solutions, such as there is a plugin for Dragon Naturally Speaking, you essentially have to do a lot of training with the individual to train them to speak the maths correctly. So what we tend to see is things like individual symbol recognition. You can say square root of, and that will be recognized, but dictating quite advanced equation structures is still proving a technological challenge at the moment.
Thank you for that. Another accessibility related question, we haven't touched on this before, is there any work being done?
Hey, Richard?
Yeah, sure.
Sorry, I want to cut in real quick, and I was trying to find the link and I couldn't find it, but there's another project that we've been involved with called Utter Math, which the goal there is it's for machine learning. Basically, we're working to build up a very large library and set of people speaking out the math equations to address that exact issue that Abby was just kind of talking about, that, you know, people say the same equation many different ways. I will find the link and I'll make sure that I'll get that to you, Richard, so we can put that in the resources. But that's a project where that's the main focus, is so that we can improve that speech recognition specifically for the math equations, which our goal is to then be able to take that and put that into Mathshare when we have a very robust model that can understand what people are saying when they say the same equation in many different.
And I know that organizations that create audio versions of math textbooks also have to work very hard to guide their narrators in how they read out the equations and expressions and so on. This, as Abby says, it's a complex area. So the question we're coming to now is there any work being done or considered specifically for low vision users? Here we're thinking about the ability to magnify the expressions and not have issues with pixelation when it's zoomed in, and you might also speak to color contrast and color personalization.
Yes, so all of the work that we're doing to make it more accessible for screen readers, we're also looking at how to make it more accessible for low vision. So all of the color contrast would be WCAG, I believe, between AA and AAA compliant right now, as well as keeping everything so it works well with screen magnifiers, both on the system level as well as extensions. We're also adding in personalization settings because we noticed there were a lot of students that we were working with who weren't necessarily diagnosed as low vision because they also had other learning challenges. So teachers would assume they didn't understand the concepts, but the problem was actually that they couldn't see the board. And a lot of these students were finding that it helpful to have personalization settings in the program itself. So we've been building those out as well. To do things like increase font size, increase contrast, use colors that are more effective. I know I noticed a question or a comment around CVI, and that's one of the folks we've been working with as well is for things like having, I believe it's red on black can be very effective, or the colors red and yellow can be very, very helpful for those students who have very low vision. From CVI specifically.
Thank you for that. So we have a couple of questions here around some of the technology underneath Mathshare here. So one is about the platform which is based on, is it something that runs at a remote server, or is it possible to run it from a local server? Does it require, if you're using it on a tablet, is it accessed through an app or through a browser? And then the last question in this space is just checking, so is Equatio related to this? Is it perhaps the math engine behind Mathshare?
Okay, taking this one at a time. So this is a web application, so this would be accessed through the browser. So not a local version, but it would be through online. Then for Equatio is not the math engine behind it, though we have worked with Equatio in the past, doing similar work. So, and then I believe, was there another piece that I missed?
So I think it was just a clarification. So if someone were using a tablet, they would be using the browser on that tablet, like Safari or Chrome, for example, to access Mathshare and to complete their work and so on.
Yes.
Great. So now again, a little bit around the scope of where Mathshare can most appropriately be used. So I think at different ends of the spectrum. So one question from Ahmed, which is, can Mathshare work on advanced maths? So differential calculus, complex numbers. And then from Sarah, she's asking that she'd love to see lower grade level materials available as well, those for students who are in early elementary, middle elementary, using a tool like this to show their work. So there we go. Tackle both ends of that question.
Matt, would you like to speak to this one?
Sure. For the elementary one, I was talking with a teacher in Minnesota that's been using Mathshare with one of her fourth grade students, where he has cerebral palsy and handwriting is very difficult. And so so she's been then adding the math problems from paper worksheets into Mathshare problem sets, and he's had great success in being able to use it that way. And then just simply sharing the link back to the teacher through Google Classroom. in the college level, you know, the main limitation there is just simply a matter of whether the math functions are available or not at this time. So like if students need access to Greek symbols or integrals or matrices, then Mathshare won't work for them right now. Those are things that we'll be adding in later on. But if it's, you know, your traditional algebraic and some of the geometry symbol or functions, if that's kind of all you need, then go for it. But I've talked with some college students that have been using it, as well as the elementary, if that answers the question.
It does, and it mostly answers a question from Blind Educator, which is which math concepts can be used with Mathshare, asking specifically about algebra. So you just mentioned that. You said some geometry, and you didn't mention trigonometry, and that would answer the question from them. So geometry and trigonometry, what kind of, which concepts there relate to Mathshare, please?
I would say, like, for trigonometry and for geometry, it's going to be kind of hit or miss based on what you need. And I think with geometry, one of the struggles could be the side of, you know, are they able to do all of the drawing that they need to do? Just since, you know, both of those can involve a lot of like graphing and being able to draw out different parts of the equations or being able to work through it in a visual way. You can do that in the Sketchpad, but it might not completely meet the needs of the materials. So I would say more on the side of like, no, Mathshare isn't something that you could use completely throughout geometry and trigonometry.
Thank you for that. We're going to take a brief foray into one topic that's come up from a number of folk, which is around the challenge of creating accessible math resources for the student by the educator or other education professionals, knowing that, for example, MathML can be a really accessible format for people, but people struggling to find tools to create that accessible material in the first place. Someone here says Equatio comes close, and are there any other suggestions? So I know it's not maybe something that we touched on too much within the scope of the webinar, but what about this issue of the creation of accessible math resources for students then to use? Someone's using an example in these times of COVID where they need to send out worksheets and materials to students that need to be accessible to them all, and the challenge that, that they're then faced with to that. And then we'll return to Mathshare again. So Abby, Matt, Alex, your comments on the production of accessible math expressions and worksheets.
Yeah,
who's got the answer?
I think we're making quite good progress. I would always start with Microsoft Word, to be honest, because that's what teachers know and they're familiar with. The built-in maths tools in Word are pretty good at school level to cover most equations, and some of the inclusion tools within Word can read aloud some of the basic maths. And we now have tools like the Word to EPUB tool that you were talking about in your webinar last week, Richard, that will allow us to take that content from a Word document and put it into an EPUB, which will give us MathML. Now, one of the parts of the jigsaw we're missing is, you know, good EPUB readers that support MathML, but if it's in that format, then we've got that MathML or even LaTeX format as well that we can then put into Mathshare. So it's about having that good editing tool that will then make it into some sort of coded maths. So I would be talking to teachers about starting with a Word document, but really understanding the maths tools in there. There are many other tools as well around where you can create accessible maths in terms of LaTeX format or ASCII math format as well. But from experience, teachers prefer Word.
Any more for any more? We haven't addressed the question that anonymous attendee asks, sorry, Andrew asks, which is, what about the screen reader user creating the math expressions themselves?
Yes, so to the first point first, around creating accessible math on the teacher side. One of the tools that's actually come out of the Diagram Center is called MathML Cloud, which is at mathmlcloud.org, which allows you to create MathML fairly easily. You can either enter a math equation or upload a file that has equations, and then hit the process button, and then it generates the MathML that can be read accessibly. Though, to Abby's point, it can be useful to have tools that are built into tools that teachers are already familiar with, such as Microsoft Word. On the point of creating the math expressions themselves, so because Mathshare is built on MathML, as you type the questions, you can either use MathML or LaTeX if that's what you're familiar with, but we found that a lot of users type using either standard math equations. Then the math that is generated is in MathML, so it can be explored in a similar way. The issues that arise from that are more around how to make those more understandable. I think Abby talked on this earlier, but math is never said in the same way. So if you have particularly very complex equations or a lot of parentheses or fractions, understanding exactly where those stop and end, how they're read aloud, keeping consistent with how you read exponents and things like that, that's where it starts to get into the weeds a little bit. So that is one place that I've kind of been looking for different tools that can do that most effectively.
And we haven't got into the possibility of using MathType from Wiris. I believe that has some screen reader support with it, and I have a comment from Dina in South Africa who is commenting to that. We still have some questions that are outstanding, but that's always the way. We'll want to be respectful of the time. So whoever has the control of the screen, maybe you be good enough to move to the wind up slide and we'll bring this to a close. If you still have questions that haven't been addressed, then it's possible for you to reach out to the presenters today, and you saw their contact details earlier. So we're coming to the end of the session. Thank you everyone who's joined us for today's webinar. Abby, Alex, Matt, thank you for sharing your wonderful information and your expertise. Coming up in the next few weeks, we have the following webinar topic. On April the 29th, we have Telling Your Story, Creating Better Accessibility Statements with Aspire. On May the 6th, we have Publishing Accessibility W3 Standards, Where Are We and How Do We Get Here? And on May the 13th, we have Easy Access to Books and Articles through a Sparts Speaker. Make sure you're signed up to our webinar announcement mailing list, and there you can learn about the new sessions as we add them. If you'd like to suggest a subject, or if you have a webinar in you that you'd like to propose, then please do email us at webinars@daisy.org. In the meantime, thank you so much for your time today, and you have a wonderful rest of your day. Goodbye.